Hello, Dr. Harris here, back with more data wrangling from Chapter 4 in our data computing course. In this video slideshow, we're going to introduce ourselves to several of the data verbs that we're going to be using with some frequency. And so I just want to give you a basic introduction to 4 of those here. Again, we're trying to transform our data right now so that we can get in a position where we can visualize it. And the data verbs that we're going to be talking about in this video are mutate, filter, select, and arrange. We have a decent amount of experience with filter already. We saw mutate just a little bit in the last example in the previous video. And so we'll start off with those two, and then we'll introduce ourselves to the data verbs select and arrange as well. So as we note here, mutate allows us to create new variables. And so we're going to be modifying our data set essentially by adding new variables to it. And so we're going to start off by looking at the country data set in the data computing package. I've got it open right here. And 2 of the variables that we have are the area of the country and its population. And so what we might be interested in doing, if we had that information, is to compute the population density for each country. That's actually not here in the data set. If we take a look, population density is not there, but we might be interested in looking at that variable. And so what we can do is we can use the mutate command. We're going to pipe out of country data, and we're going to add a new variable called pop_density, and we compute the density by just dividing the population by its area, whether it's in square miles or square kilometers. And then we get a new data set with this added as a variable. And so what we can do is we can pipe out of this, and we're getting a little bit of sneak preview of our command select. What select is going to do is it's going to pick out just a few of the variables from our data set. And so we can select the country name, its population, its area, its density, and then we can look at the first few items in this mutated data set. And so if I come over here and plug this in, we see that we do get the country, the population, the area, and the population density, and those are listed, and we just have the first 6 here. That's what head does. It just lists the first 6, or in this case, since we said n equals 6. And so mutate is the new thing here, the key thing here. What it did was it basically created temporarily, at least internally in our studio, a data table that's got another column in it, population density. So we're going to be wanting to use mutate from time to time when we want to create new variables from the ones that we have. We saw that in the previous example, last slideshow, where we wanted to create age groups. So if we don't have a variable that we need, we want to remember that we can use mutate to create it. And so here's the output in a nicer form than what we saw out of the console. And so just a reminder about there are some differences between mutate and summarize. We do need to define a new variable in each case, but remember that the summarize is going to be using a reduction function, so it's just going to be computing a scalar from a data variable or one or more variables, whereas mutate is going to create a new variable. And so we're going to be applying a transformation function inside mutate. So reduction functions inside summarize, transformation functions inside mutate. And so summarize is going to be giving us a number, mutate is going to be creating a new variable. So that's a brief introduction to mutate. Let's spend a little bit more time with filter. And again, we've got a nice description here of what filter is actually doing. Is we're actually removing cases, rows from our data table. So filter is going to be used to select only the cases, the rows in our data set that meet certain conditions. So Just some quick examples here. If we wanted to only look at the males in the M111 survey data set who prefer to sit in the back, we would use the filter command on M111 survey. And rather than separate these with commas, probably what we're really going to do much more frequently is to use the logical operator and. And so if we wanted both these things to be true, where we filtered out and we got only those individuals who were both male and wanted to sit in the back, preferred to sit in the back, we would hook them up with the ampersand. Look at a couple of other logical operators that we can use. Not equal to. So let's think about what this would give us. This would give us all the individuals who don't prefer to sit in the back, and as well as those who aren't male. So this is going to wind up giving me the female respondents who responded either front or middle for where they prefer to sit in the classroom. So we want to keep in mind not equal. And we don't have to apply not equal to both of these. We could just do it to one of them. If we just wanted the women who prefer to sit in the back, we would have said seat equals 3_back and sex not equal to male instead, as opposed to not equal as sex equals female. So notice that for the equals, though, we're actually using the double equal sign for these logical operators here. But the vertical bar is going to be our symbol for or. So this would give me the respondents who are either male or those who prefer to sit in the back. So it would give me all the males as well as all the people who prefer to sit in the back, including those that satisfy both of those. So we want to keep in mind that there or is a possibility. Hopefully we would be judicious in its use. And so we can use also logical operators like greater than, less than, greater than or equal, etc. Or we used in our filters as well. So we want to keep in mind that we're always looking for those. We want to figure out what is it we want to find, and then set up logical operators and strings of logical operators that will return true for us. So we're going to be the ones that meet all the conditions that we lay out. So another important one is is.na. And so when we apply is.na to a variable, that's going to return true or false, depending on whether the response was given or not. So if the response was not given, if there's an NA or no response in a cell in our data table, then is.na will return true. And so what we're doing here when we filter on is.na of GPA, we're identifying all the individuals who did not respond to the GPA question. And it turns out there was only one, a female, whose height was 67 inches and who reported going fastest as 90 miles per hour in a car. And we can see that there is indeed an NA there for GPA. Much more frequently, though, we want to filter on those that actually did respond as opposed to those who didn't. And so we're going to put the exclamation point in front of is.na. And when we filter on that, that will return all the ones who did respond to the GPA question in this particular case. So exclamation point is.na is going to be a reasonably frequent construction that we at least want to consider. We want to weed out all the NAs. And so here's where seeing how we can chain together a few conditions in our filter. If we went to the baby names package, if we wanted to look at all the male babies who were given the name Bobby, B-O-B-B-I-E, in the years 1920, 1930, 1950, 1970, and 2000, this is how we could construct that. So we'd filter on name is Bobby, and sex is male, and the year of birth is one of these five. And then it prints out this table for us, and it tells us how many individuals were given, had that name in each of these years, as well as the proportions. So that's filter. Filter is a powerful command. We'll be using it quite a bit. So that, as it says, removes cases. It cuts down on the number of rows that we're looking at in our data set. If we want to cut down on the number of columns that we have, we're going to be using the command select. We saw that a little bit earlier at the beginning of the slideshow, but select allows us to choose only certain variables, certain columns from our data set. And so if we wanted to filter on those males who prefer to sit in the back in the M111 survey set, but only look at a few of the data values, we could select their sex, where they prefer to sit, the fastest they've ever driven, and how they feel about their weight. And we would just print out, it would just print out those values for each of those individuals. So select is good at choosing only variables that we want to consider. And so if we've got a big data set and we don't need all of the information that's contained in it, and we're going to be doing some data crunching, we can just select at the outset those variables that we know that we're going to be working with. So here's another common, reasonably used data verb, na.omit. And so that's going to eliminate, as it says here, all the cases in which at least one response is NA. And so if we applied na.omit to the NCHS data set and counted the number of rows that were left, we would see that there are only 12,000 people who responded to all of the variables. So there were over 31,000 rows, but only 12,000 of them gave responses to every single question. If we select first and then apply na.omit, then we see that we get more responses, but these are the number of individuals who responded to both the height and the smoker question. So when we do a select before an na.omit, we're going to get very likely get more data values. And so we want to be judicious about when we apply na.omit, and we may want to do our select first. And then finally, the last data verb that we want to look at least briefly right now, is the arrange data verb. And that allows us to sort our data. So we've got the Minneapolis 2013 data set here. If I look at that, what I've got is individual voters. So our cases are voters. We're told what precinct they voted in. And this was a ranked ballot. And so they indicated who they preferred first, second, or third. Some people chose not to pick anybody beyond their first choice or beyond their first or second choice. But what we're interested in is we want to count and sort and arrange this data set, rank the candidates based on who got the most votes as their first choice, as part of a first choice. So who are the top first choice vote getters? And so we can use a group by and a summarize here. And we group by the first, and then we count how many votes each individual got after we group by first choice. And this is just a partial list. Here are the first 5 candidates listed in alphabetical order by first name. And so we can see we've got the candidates and we've got the number of votes that they got. But if I want to sort this, I need to think about how I'm going to get the list arranged, probably from the highest number of votes gotten to the lowest. Well, arrange is going to be a useful data verb for us. So if we group by who they chose first, and then we summarize the number of votes each received, and then we arrange them, we see that we actually wind up ranking them from low to high. And that's not what we wanted. We don't want to. We're less interested in John Charles Wilson getting the least number of votes, as we want to know who are the people who got the most votes. And so if we want to arrange things in descending order, we're going to apply the function DESC to the number of votes. And so if we arrange in descending order, this is how we're going to set that up. And we do indeed see Betsy Hodges was the leading vote getter, Mark Andrew was second, Don Samuels third, and so on. So that's just a brief introduction into arrange. And so it gives us, all together, this gives us a little bit of sense of how we use mutate, filter, select, and arrange. We've got much more to do with that when we get to class.